Cool. Yeah. So I think I'll just like poke around a teeny bit then. It sounds like folks are a little bit familiar with kind of Ethereum, and I think that there's good distinctions to make. But I will be sharing this screen. Let's see. Can we see this pop up? No. Okay. 1 second, actually. I will do a little switcheroo here so that it's best for sharing. Screen one. All right. Yeah, so just like little things to point out. You know, there's MetaMask, and basically this is how a lot of people would use Ethereum, and Ethereum has got some good stuff going for it. I think there's a lot to be improved on, which is why there are so many blockchains, including Near. And typically when you have something that you are trying to transact, you can look in the activities, and here's a bunch of things that I did. Here's a failed one. And so there is like Etherscan that you look at for all of your kind of transactions. So we have like Near Explorer, which is like sort of takes the place of this and actually has quite a bit more details, especially our Explorer has the details about like you did a cross contract call, it did multiple actions, what all happened, was there gas refunded, was there transfer of Near that happened, what was the result, what were the parameters, all of that. So this is what it looks like though for Etherscan. And one thing that is interesting to note is that if I were to try to do like 2 transactions in a row, you would see that there is like on this activity, like one is like pending, and then there'd be one that's like queued. And that's because every time you do a transaction, it basically says like, hey, you're always going to do transaction 6 before you do transaction 7. And so you have like a nonce, like a number used once. And so you are kind of like in Ethereum, at least for this one account that I have right here, you have a nonce that just is incrementing, and it's kind of like not parallel at all. Just that's a little side note to say that like in Near, our accounts are not this long like hash, but they're actually human readable, and the name can, you know, your account is actually the human readable name Mike.Near, and you can add and remove keys to it, which actually is a huge deal. Each one of these keys, by the way, if you have like 3 keys, those have their own nonce. So they're kind of like independent. So you can get into a point where there's a little bit of a log jam where you're waiting for one nonce to finish before like the next one goes. That isn't always going to be the case for Near. So that is a kind of a cool thing. And then, yeah, just something that to sort of show. This is a DeFi app. You know, there's a bunch of DeFi apps out here. I listened to this really great cypherpunk interview with Arto and Frank Braun from the Aurora team. And Arto said something really good, which was like last summer, basically a year ago from this recording, it was a little bit up for grabs. Like, what is going to happen with blockchain? Is Ethereum really going to be like the blockchain for things to happen on? And then DeFi summer happened, you know, probably almost exactly a year ago. And that has really made it so that a lot of decentralized finance is happening on Ethereum. Here's one of them. And this is really like something that is making it so that we want to have like an EVM, which is why Aurora happened. So basically here is, I'm not going to actually do it, but if I wanted to withdraw some money, then the workflow is you click withdraw, and MetaMask, which is a browser extension that has like securely, you know, it like hid my private key, pops up and it says, hey, do you want to sign this? Hey, this is going to cost you like $11 to do this. So just like a little bit of a difference in UX, let's just talk about for a sec. This is pretty typical. I would say that there are a lot of different wallets, but a lot of folks are still using MetaMask. So we can focus on that. So you do an interaction with the website, right? And then your extension has your private key, and then it pops up. So obviously we'll get to this a little bit later, but it's like in Near, it's typically like you want to do a transaction, nothing pops up. Instead, you get redirected to Near Wallet. So this is a bit of a different like UX. I don't think that this is like news to anyone, but I think it's a good thing to just highlight like the basics. Reject. Okay, cool. Are there any like sort of like, before we get started with how to make a near crossword puzzle, are there any sort of like thoughts or like tingling questions now that we talked about Ethereum for a little bit, where the people want to ask like, wait, how does this work? Is this different? Anything like that?
Yeah, the wait for the okay, so for like the access keys for near, you said like each one has its own nonce. Like, do you
Yep.
mean like the creation of a key, or like for the key itself? Like, what did you mean by that?
Sure. So one key will have its own set of like nonces that like go up and up. So like I want to do 5 things on my DeFi app, and my since my account in Ethereum is actually like my key pair basically, then I have to wait for one to get done and then do the next one. What you can do in Near is that like if you say you want to have like a very rapid fire sort of set of transactions, you can actually have like 5 different keys that will all have their own nonce. So like key 1 is not waiting for, or key 2 is not waiting for key 1's transaction to finish. There are like, you can kind of parallelize it.
Oh, okay. Oh, I see. I see what you're saying. Cool. Thank you.
Yeah, it's kind of a small distinction, but that gets important later, and I think it's good to bring up in the beginning. Cool. So the crossword, I think this is a really fun thing to do. It's good for docs, and I think eventually this is going to be something we can use to like give people like, you know, hey, solve this crossword puzzle, and you can get some near, which is fun. So a little bit meta on these slides. We're going to start out with a crossword puzzle being like a piece of paper, and then people will like submit their solution using, I think, the CLI tool. We may actually choose to do it a little bit different later, but yeah, we'll take a look at different versions of how we would do this. And in the beginning, just to keep it kind of like simple, we're going to just start out like someone sees this crossword puzzle and they want to play with it. So we're going to look at it from that perspective. And so during this first part, don't worry about like, wait, how did this contract get written? And we will talk about that after. And a whole bunch more, yada, yada. So actually, real quick, Jim, you haven't seen this at all, have you? I think Fong may have seen a teeny bit. Okay.
Yeah, I haven't seen it at all.
Okay, great. So bear with me, Fong, as we reiterate a little bit. So this is the kind of fun idea is there's a bunch of, as anyone knows, I think Jim is actually compiling a dictionary of all these different terms because blockchain, it just has so many acronyms, so many words that the idea is to make a crossword puzzle that the answers are like blockchain ideas. And so maybe someone could look at the near docs and kind of hunt around for these answers and fill this out. So you have like sharding, sub-accounts, etc. And so like let's say that like once you complete this crossword puzzle, you can take these words and you can actually make a seed phrase out of it. In this example, like let's say that we say, all right, well, take all those words and then like 1 across and then 1 down and then 2 across. And if there is a 2 down, then you add that. So the seed phrase would be sharding, sub-account, access key, blah, blah, blah. What is a seed phrase? Does everyone kind of know what that is? Nice. Yeah, so it turns out seed phrases they don't have to be using any sort of like special word lists or anything, but I won't go into that. So you can actually make seed phrases out of like whatever words you want. So here we are talking about the paper and pencil crossword puzzle example. Here is how you'd use currently the CLI to like generate a key pair. Now this isn't touching the blockchain at all. This is like one of these just strictly like utility functions of the CLI. We say near, generate key, and then we say, all right, we're going to make it for this account called like v0.crossword.puzzle.near. Here's a seed phrase, and it will create a JSON file in your home directory with a private key and public key. And just because it's handy, it'll spit it out in the console and say, hey, by the way, I created that key pair. Here's the public key that's going to be visible by anyone. So this key pair is created. Let's talk about keys. This particular kind of key that we made is a file system key store. We will get to the second one a little bit later, but these are currently the three kinds. You can have browser local storage, which you probably have seen in your wallet. It's actually stored inside of your local storage there. And then only computer memory, which may not be used as frequently, but you can just say, hey, I want to input this thing and just hold it in computer memory and use it. So obviously in this case, we generated a file on the computer. And these are in the home directory under a subdirectory that is for the network. So testnet, mainnet, etc. At the bottom there, highlighted in yellow, that's what the path would look like on like Linux or Mac. Okay, so back to actually being this user playing with this smart contract. Here is a near CLI command that you might use. Again, we haven't really made this, so it's just sort of like brainstorming. You'd say near call the crossword puzzle. The method is submit solution, and then we throw in some arguments. So I like this idea of having like a memo here, which is like, you know, saying, hey, Mike is the king of the hill. You have some sort of braggadocio message saying that like you were the first one to solve this puzzle. And then let's think about maybe having like a second parameter, reward account. So if I win, if I'm like the first person to solve this, hey, send the, you know, 10 near, whatever the prize is, to the account mike.near. And this is a kind of interesting is this last part is a flag saying like, I am calling from v0.crossword.puzzle.near. This is a little bit interesting because typically you will say, I am Mike.near and I am calling into this smart contract, right? In this case, we're kind of saying like, I am the crossword puzzle and I'm calling the crossword puzzle. This will all make sense like a little bit more later. So what's going to happen inside the smart contract is it's going to have the inside smart contracts. You can say, hey, you can say a number of things. How much gas have I used? How much balance do I have on this particular smart contract account that I live on? What is the account name of the person who just called me? What is the public key of the person who just called me? And that one is going to be the important thing here, because we have solved this puzzle. We have all the words. We created like a key pair out of that. And so what can happen here is that the smart contract can say, I know that like you actually solved the puzzle if you are sending this message to me and you signed it with a key that has this public key. Does that make sense? Sweet. And again, and then just kind of going over the memo thing just to kind of make it fun. And also this could tie into other things later. The memo gives you that like sort of like retro arcade feel where, you know, here's a stock photo that I got of people saying like, oh, this is Eugene, this is David, this is Josh. Although in real life, it's usually like swear words or something lewd, but still, you get the point. There's a little bit of space, like a string that you can add in there. And as long as we're talking about this, like the second point here, just as we brainstorm how we want to build this thing out, like it would be cool to store all the winners with their memos, and then maybe like some function that's like, hey, give me like the most 10 recent winners of like the most 10 recent crossword puzzles. So that would be a cool thing to have, and having that as sort of as a goal is going to help us explore more concepts in near. Okay, so this is kind of interesting. Wait, time out. Here before we were saying like, all right, I'm calling this method submit solution, and I could just give it like parameters, right? I gave it a memo with a whole bunch of words in it. Why can't I just give the answer to the crossword puzzle also as like a, you know, parameter that you just pass in? Well, first of all, it will be more fun to dive into how keys work if we do it this way. And secondly, this is really interesting because there's this idea of front running. I don't know if you guys have heard about it, but essentially people who are maybe helping run the network, they can kind of mess around with things a little bit, and they can say, oh, hey, I see that someone is trying to send a transaction. This is like in the waiting list, like a queue of transactions that haven't made it to the blockchain yet. Someone's trying to send a transaction, and I can see what the parameters are. How about I send that transaction right before them? And that's like front running. So this actually is kind of a cool solution, because you cannot front run this because you're not sending the answer as a parameter. If you're trying to be malicious, you actually have to solve the crossword puzzle. There's like no way around that, which is cool. This is like, I feel like I will say once a year, I will say I want to try to give out like 5 things that you must read. This is one of them. Like, you got to actually read this. Ethereum is a dark forest. It goes over these guys in this riveting story about how there was a few $1 million locked up in a Ethereum smart contract, and they discovered it, and they tried to rescue it, and it's amazing. But that will really get you like psyched on front running and all that. Okay. Of course, like any competition, first person to solve it wins. You got to get a pen. No one's ever solved a crossword puzzle without a pen. You got to solve it. You got to install near CLI and create the key pair. Send the transaction to the smart contract that has the crossword puzzle, and then profit. It says that's sort of a recap on what we're all doing here. Okay. So that's purely from like the user trying to play this game, right? The solve a puzzle. So what happened before, just high level, like obviously someone wrote a smart contract. Someone, maybe the same person, crafted a puzzle and the answers. And another requirement, there's got to be at least 10 near inside this contract if we're going to pay out 10 near to the winner. And then this is where it's kind of interesting, is then we added a function call access key to this smart contract. And this doesn't, or I should say to the account where we deployed the smart contract. And this whole function call access key thing is 100% near. Like, this is how the account system works. I have not heard of any other blockchain that does anything similar to this. So this is where it gets really interesting. Let's see. Up here at the top here, we have a recap of the key pair that we created earlier. Remember when we just fed in the seed phrase and it spat out the public key? On the bottom here, I have used another utility inside of near CLI that just says, show me all of the keys associated with this account. As we just talked about, you can add multiple keys to an account. In this particular case, we just have 2. And that top one is a public key, and it matches C, P, Q, W, P, blah, blah. So this is the key that we had added. Right here, you can see that it says function call access key. The second one, kind of in this bottom section, is a full access key. These are the 2 different types. There's no other types than near. And here is a list of method names. So you'll notice that, yeah, this is all this. What this means is you're only allowed, anyone who has this key is only allowed to call this method. You try to call some other smart contract that's not v0.crossword.puzzle, not going to work. You try to call this smart contract with any other methods, not going to work on a protocol level. I should note that there's a little bit of a counterintuitive thing here, where method names, like if this were an empty array, if this were just like open bracket, closed bracket, you might think that like, oh, that means that you can't call any methods. That actually doesn't mean that. It means you can call any method. So this is a little bit of interesting, it's like an asterisk, right? So might as well point that out as long as we're here. Okay, cool. So we talked about this function call access key, right? Well, let's talk about access keys. Function call access keys, great for logging into decentralized apps. If you guys have looked at some of our examples, like Guestbook or something, the first thing you do when you get to Guestbook, is you like log in. And I'm not going to actually open up Guestbook, but since this is being recorded and people may not know, near.dev will get you over here, or just examples.near.org. And Guestbook is an example you can set up. I actually won't do that, but here's how you find it. A lot of these examples, basically, they'll have a front end, and there's going to be like a login button. And what happens is you get redirected to Near Wallet, and then you like come back, and a function call access key has been created. And nice. Okay, function call access keys, they're also great for onboarding users who don't have a Near account, because you don't actually need to have a Near account to use them. And sky's the limit. Frankly, I don't think that we've actually flexed all the stuff you can do with function call access keys. I think that this is like huge. Full access keys. These are the ones that you can do anything with the account. You can delete the account. You definitely want to protect these keys. Yeah, they can deploy a contract. They can send your Near tokens. They can delete account. They can add in key. They can do other stuff. And all of these are other powerful actions. Notice that actions at the bottom here in red is highlighted. Let's talk about actions. So before getting into all of them, like what are the like under the hood actions, capital A actions that we're talking about for this crossword puzzle? So first we created a key pair, again, that didn't really even touch the blockchain, that just ran some utility logic. And then we use that key pair to send a transaction that calls a method. And then we've been able to see what other keys are available on that account. So the actions here, when we submitted our solution, that was a function call action. When the puzzle was getting started and it added the function call access key, that was an add key action. And then, of course, when someone wins, you're transferring 10 Near to them. Here's all the actions. And like it almost looks like it's a lot of actions, but basically, when you think about it, if you have the ability for keys on an account, then of course you need like CRUD, right? You need to like create a key, or you need to add a key, you need to delete a key. Then we have this idea of an account can create like a sub account to it. So Mike.near can make aloha.mike.near. So now you have to be able to create an account and also delete account. Function call and transfer we've already gone over. The only one we haven't really gone over is stake, and we won't really worry about that. That's actually for validators. That's kind of like outside the scope of this, and you probably won't really use that unless you're deep into validation. And at the bottom here, of course, we have nomicon.io, which I didn't realize this for a little while. Like I thought some community person contributed to the site, but no, this is the official like Near spec. That's why I was like, wow, this is like such a good site. Who made this? It's like, oh yeah, this is our site. And so yeah, this screenshot is from Nomicon. You can always visit that. Yeah, Dorian.
Okay, so when would you need to use the add key? Like if you're creating an account, are you creating a key for the account automatically? So when would you ever use add key?
Are you saying when would you need to?
Yeah, I'm wondering, is like I feel like you'd only need to ever like add a key while you're creating a new account, right? But like, or is that not right? Like, is another situation where you would use add key?
Yeah, sure. So is this actually happening all the time when we use like Guestbook? So if you like are saying like, hey, I want to log into Guestbook, that's like sort of like not the most honest way of saying it. What is actually happening is you're saying, hey, please redirect me to wallet.near.org where I have a full access key. And hey, full access key, you're allowed to do all this powerful stuff like add a key. Please add a key, function call access key that has this public key. So what logging in is adding a key.
Oh, I see. So it's like you're taking an account that exists on the wallet and then you're adding a key to an application again, right?
Yep.
Okay, I always forget. It's like you're not using the same key with the application. You're using like different keys for every new application you're signing into.
Yes, yes.
Okay.
And totally. And another thing to just sort of like mentally think about is like, you know, private keys, like you never are going to be sending that over like the internet, basically. So like when you're generating a key pair, like that's going to be completely on your computer, and the private key just always lives like in the JSON file. When you, before you log in with Guestbook, you open up Guestbook, it says login, you haven't logged in yet. When you click login, it's not going to send a private key over to wallet. What it's going to do is it's going to say, hey, pick a random number, browser, and then create a humongous private, or yeah, create a humongous number out of that, which is basically synonymous with private key. Store that private key in local storage, and I'm going to now like keep that there and send the public key over to wallet so that wallet knows to add a key with that. So the only place where the private key is in the local storage of Guestbook.
Mm-hmm. So wait, why? Okay, so how does Ethereum do it? Like, do they use like, is it like one singular key pair and it's giving out the public key to like different like applications, or like saying like this is the key that you would use to like, you know, reference an account to sign these like transactions, or like is it something similar to like what we're doing?
Yeah. Whoops. So in Ethereum, like your private key is like behind the scenes, and then this, my account, is actually like a truncated version of the public key. Like this, for all intents and purposes, this is the public key. Like your account is the public key.
Mm-hmm. And is it just that public key alone that's being used to sign all these different transactions for different smart contracts?
Yeah. So it's behind the scenes. The private key is the one that like signs the transaction.
Oh, okay.
Yeah.
Okay. I'm thinking mostly getting it. I think I have more questions, but I don't want to take more time.
Yeah. Cool. Yeah. I appreciate the yeah. Great questions. All right. Okay, so this, we'll get into sub accounts too. So the actions we discussed, yeah, this is interesting. This is very kind of important distinction. The actions have been kind of like, and I kind of hate to say this, but it's like kind of wrong, but it's kind of right. So let's just go with it. They're like sent to the blockchain. Like we did a near CLI account or near CLI command, you know, that was like deploy the contract, or please call the function that I'm like submitting my solution to this crossword puzzle. So that feels like we're like lobbing a ball into the blockchain. You can also do actions inside of the smart contract, and they are obviously like the same capital A actions. So inside of a smart contract, you can also say like, hey, when someone calls this function, I can add a key to myself. I can remove a key from myself, and you can even like deploy to yourself. Yeah, I think you can even like delete yourself from inside the smart contract. So this is very important when we think about how you might like upgrade later on or something like that. An interesting use case that I've been like really psyched about recently is a friend and I are hacking on this project, and we are going to make it so that like you have a like DAO that would be able to call it. You can say like, hey, I want to like send a okay, well, we're not going to do this, but I want to send a transaction from my DAO that everyone has to vote on. And what we could do is we could say, everyone needs to vote on us removing all the access keys. And then a transaction can go into someone's smart contract and do these powerful things. Once you've removed all the keys from a smart contract, no one can deploy to it. It is like, it's donezo. It's like, yeah, immutable. So yeah, this is the kind of stuff that you can do with actions inside of a smart contract. All right, sub accounts. I think everyone knows this, but go over it real quick. Sub accounts are only really pertain to like one level below it. So I can make like aloha.mike.near from mike.near. I cannot make like hello.aloha.mike.near from just mike.near. It always has to be like one level like below it. There's kind of an analog here where like I, for instance, own mike.exe.eth, And this is like called like Ethereum name service, which is kind of like DNS, but like ENS, right? It's super cool. They actually use NFTs. It's really interesting. I don't even understand exactly how it works, but sometimes people will think like, oh, so are you guys like using ENS? And it's like, no, we're not doing that. Like in a near, like your account is actually Mike.near. It's not like there's a human readable thing called Mike.near that is like somehow like referencing something else. No, like just to make that distinction, ENS is actually quite different. Okay, so yeah, I think I wanted to highlight on this. An account can deploy. Oh yeah, during the creation of a sub account. So we talked about making a sub account. Let's actually, this is a little bit strange, but let's just talk about batching actions, which is important. Have you guys heard of that? Like batching actions, batch transactions? Have you heard people at Near talk about that?
Nice. I've heard it. I don't understand it.
Okay, cool. Perfect. Yeah. So you can actually batch actions inside of a smart contract. We already saw that the list of actions, there's only like, what, like 7 or something. So for instance, you can like say, hey, I want to like create a sub account, aloha.mike.near, and then I want to like deploy some smart contract code to it. And then I want to like call like new, the function new on it or whatever. You can like chain these events. So now we're going to look at some Rust and just this middle part here where we're saying like promise new, and then you got this whole chain pattern. Create account. Transfer. Now we're going to add a full access key. Now we're going to deploy a contract. And so this is what it looks like when the rubber meets the road here. Dorian, you have like a very thoughtful look on your face. Do you have questions, or am I imagining that? Okay.
No.
Just soaking it all in. Okay, cool. Nice. This example was taken from Near SDK RS, and there are a bunch of examples in there. And like, I think it's worth like kind of like memorizing them. Maybe not, I mean, not like memorize, but like these are so useful. And until we get our docs like really shored up, like this is how to understand how a lot of this stuff works. So that's batching. Sometimes you'll hear people say like batch transactions, and actually I kind of want to like nix that because it really is batch actions. And the reason why is because you cannot say, I'm going to batch, creating this account, and then I'm going to make a function call to a different account over here. Like you can't do that. Like you're batching actions to the same account. That's the only way you can do it.
Sorry, I did actually have one question I think about it.
Cool.
Can you go back one slide? Promise is coming from Near SDK RS, or like the Near SDK, is that right?
Mm-hmm.
Like the crate itself?
Yeah.
All right, cool. That was my question.
Awesome. Yeah. Oh yeah. So here we go. Let's just like take a step back for a little bit and be like, okay, what are the needs for the crossword puzzle like MVP? All right. So creating the puzzle, coming up with an answer, solution to it. Okay. All you need is your brain and Near docs. Got that. Deploying the contract, you're using CLI. Adding a key, also use CLI, and then making sure that there's at least 10 near there. You could also use a CLI saying like, yeah, near send crossword puzzle 10, basically. That's from the kind of contract creation side, right? Person playing the puzzle, playing the game, they need to create a key with near CLI. They need to submit an answer with near CLI. Okay, is that it? And the answer is no. There is kind of like one more thing that needs to happen here, which is, what if they don't have a Near account? What if you don't have Mike.near? What if you're just someone who wants to like play this game and you're 16 years old and your parents aren't going to let you go through KYC on an exchange to buy Near? Like, how do we deal with that? Okay, well, there is a way to do that. But let's like not get crazy, and let's just talk about different iterations here. So the first version 0, pen and paper only. And so what this means is like you got a piece of paper, crossword puzzle, computer with internet that can presumably install near CLI, and then you just do everything that we just talked about, but you need an existing near account. You say, oh, pay out Mike.near. What if a person doesn't have this? So that's a requirement. Version 1, after this, we can create and send this reward to a mainnet account. So the needs are just sheet of paper and computer with internet. Pretty darn awesome. And this will kind of force us to deal with cross-contract calls and promises as we can we actually create an account for someone else? As long as we're dreaming, iteration 2, or 2 out of 3, if you want to think about it that way. All you need is a computer with the internet, and we would have a front end to this. So someone can just go to some website, and it's a crossword puzzle, and they don't need the near CLI. We just use near API.js, and near CLI is using near API.js under the hood. So this is kind of the most easy way for someone to actually get an introduction to blockchain. You don't need a near account. You don't need a CLI. You don't need to type commands, anything. It's just can I solve this crossword puzzle? As soon as you do, it sends it off, and maybe you'll win 10 near. That is pretty awesome. I don't think you can do this with other blockchains as far as I'm aware. So this is kind of the dream. All right, but chill on the scope creep. Let's go back to version 0. So they need to have at least 10 near, right? It needs to have a function called submit solution, which we kind of hinted at might be a good name in our near CLI screenshots. And this will check to see, hey, is it what's the public key of the signer? How do you do that in Rust? You can hunt for it, or you can just, here's a little hint. It's env signer account PK, public key. Then we're going to want to store the memo, that little bragging message, right, on chain somewhere. And then we're going to want to use the transfer action for the 10 near, inside the smart contract. Again, you can find this Rust in a few of the examples, but this is exactly what it's going to look like. So pretty simple. Promise new, Mike.near .transfer 10, and that would make the smart contract transfer 10 near to Mike.near. Version 1, we want to be able to create a new account, not a sub account, by the way, an actual Kevin.near account, and send a reward to it. So this is going to make a cross-contract call to the network. Network, obviously in blockchain means mainnet, testnet. This is going to send a cross-contract call to the top level account. And that's a fancy term for testnet or near. These are actual accounts. There's actually nothing, as far as I know, there's nothing different about these accounts than Mike.near. They are the same thing, right? And so when I made Mike.near, that's actually a sub account to near. It's just as simple as that. I don't know if other people had that confusion, but I don't know. I thought there was something special about them. I don't think that's the case. Maybe they are, designated as special inside of a Genesis configuration or something. But for all intents and purposes, it's just an account. And then this last part is really interesting that can serve as a cool learning point. We need to figure out what happens if you say, cool, hey, send the reward to, my name is also Mike. Send the reward to Mike.near, and you think that you're going to create the account called Mike.near. What if it's already taken? Something like that. So we need to say, okay, how do we handle errors? How do we say, I'm doing a cross-contract call, and I want to see how that went? If you know that, you know a ton about smart contract development on near. Okay, so we're going to stay on this train of how would the user who doesn't have a mainnet account, how would we kind of accomplish this? So this is from the link drop source. I will send you guys this. Everything is, I'll send you this presentation as everything is linked in here. So this is a little snippet we'll look at. Promise new, we're going to create an account, add a full access key, transfer, and then we're going to, this is a really kind of ugly long line, but basically this is saying, and then we're going to call ourselves at a function call that is named on account created and claimed. So does that make sense? Like this is like promise.then sort of stuff that you know from JavaScript. This is kind of similar, but we'll get into the differences. So then inside of this can be thought of as like a callback, and we'll have some information on how all of this stuff went. So that's how you can say, cool, we tried to create an account called Mike.near and do all this stuff. How did that go? And then inside this function, we'll be like, oh, it failed. Okay, cool. Well, like maybe let's ask the user for like their second idea for an account, and maybe that one like is available. I think I will actually skip this and this, and I covered that. Okay, this is important. Maybe Dorian, this is feel free to chime in, because this is, for some reason I feel like this is going to be up your alley and maybe something that you've run into. JavaScript promises are different than what we're talking about here. So like let's look at async await in JavaScript. That highlighted part at the bottom, let values equal await, and then it calls out all of these different promises. And so the idea is it's like, yeah, the assignment of values will kind of like wait for all this stuff to happen. Okay, I've seen people do this, like very smart people do this, and this is a sign that we need to improve our documentation a bit. But this is the wrong way of doing it. You cannot say like let creation result equal promise.new, create account. It's like a smart contracts, they just kind of spin up and then they spin down. And it's not like you can spin it up and then it waits for something to spin up, and then because that could also call another one. No, like you can't have assignment like this. That won't work. So what you have to do is similar to what we just saw before. Promise.new, like create the account. Then please call me at this method, and then this will get called here. This is the nice little decorator that we have that is basically a shortcut saying like no one else, this is public. Technically, this is a public method, but no one else is allowed to actually get anywhere with it unless you are me, right? Because this, I am calling myself after this is done. And so you can do stuff like, is the promise successful, blah, blah. So that's how you do it.
Explicit assignment is really just referencing the method there. Like you have to have like a true async callback.
Yes. Yes.
Okay, cool.
And then another one too, where it's like REST promises are also different in this sense that like, and this is maybe a little, yeah. Well, let's see if this makes sense. But you can say like .then, and if one of them kind of fails, then all of the rest of them like fail essentially, right? With JavaScript. I made this as a little like code pen that is probably not even worth going into, honestly, but you can look at it later. But it just shows that like if you uncomment like the bottom line, then we'll only see the console log. Let's see here. Yeah. Okay. So the bottom line, right? We're throwing an error, right? So you would expect that this is all like the whole thing is going to fail. Makes total sense. I think everyone's kind of with me on this. Let's just go straight to how promises work that are differently. You can chain multiple .then calls, but when that call finishes, all the promises will be recalled regardless of whether the previous one failed. So yeah, maybe I can clean this up a little bit because that's just the meat and potatoes is like it's not going to act the exact same way. If you have like 3 .thens, all of them are going to get called, which is cool because sometimes you actually do want to have almost like a try catch finally thing where the finally is like no matter what, like please do this block of code inside of finally. Nice.
Yeah, you can self clean up like
Totally. Is this all making sense so far? I wanted to check in a little bit. Cool.
Yep.
Okay, yeah. So then highlighting the figure out what happens if the new account is already taken or is invalid. So that that's where it happens, is that callback. That's where you can say like, did this thing fail? And if so, then I may want to like revert something or whatever. Okay, yeah. Let's see. I see it's 12:50, and I do want to keep going. I'm also like wondering how is everyone doing on time? Like if people go over a teeny bit, if they would they want to?
That's fine with me. Yep.
Awesome. Cool. Then I won't try to like super duper rush. And of course, feel free to drop off. It's not going to offend me or anything. Okay, so we are a Rust first smart contract platform. And Rust can look scary, and it is sort of scary. The good news is like the SDK that we have is like takes a lot of the really crazy stuff out of it, and you're going to be doing the same thing kind of like over and over again. And so this is a lot less scary than you think. But just sort of like looking at this smart contract right here, it looks kind of like a lot. So let's just like break down what's going on. The imports up at the top. And then we even have something that this will actually even be shorter now because now this is gone thanks to Austin and Fong's work. So we got this import section. Let's forget about that. Now it's getting shorter. Then you got your contract fields and methods. This is using structs. You have a struct, and then you have like an impl for it. Okay, cool. So there's that section. And then the bottom part here is like your unit tests. So like hopefully this is like mixed into blocks that were like a little bit less scary, just kind of compartmentalizes it. And yeah, since we've got such a good SDK, there's an official Rust book that you can get that's online. And you really need to only go over the first few chapters. Like I had said for a while, like the first 4 chapters, and I'm looking at it, maybe it's like the first 11 chapters. I would say you can time box like 45 minutes, like just to look through this stuff. Boom, like you'll know enough to write Rust smart contracts. But if you're looking at this book, there's going to be some examples that will show you some helpful things. So like, I want you to look at this Rust book if you want to, but also like note that like, there's going to be some stuff that throws people off and has definitely thrown me off. So for instance, let's talk about this whole like memo idea, like the bragging message, the retro arcade thing, right? This is a screenshot from the Rust book. And it's like, all right, cool. You know, you want to have a winner and then their memo. Cool. Well, that's going to be a map. Let's use hash maps. And so you have this whole section about that. But if you like, let's say people just love crossword puzzles and you get to like 2025 crossword puzzles and they're all stored in a hash map. Well, that's actually not going to be that great because hash maps, when they're used in smart contracts, they will like load the entire thing into memory. And you don't really need to do that. And, you know, one fun thing about smart contracts is we get to be like really like finicky on how much like computation we're using. And so it's really not efficient to use hash maps for this. So this is kind of the introduction to like specialized collections. So yes, read the official Rust book, but also know that like you're going to want to be aware of these like specialized collections. And here are some currently. I think they're probably going to add some more later on too. So yeah, I guess I won't really go into these, but in particular, like lookup maps are used a lot. Unordered maps are used a lot, and some of them are iterable and some of them are not. And the ones that are not iterable, meaning you can't like go through them, like iterate, obviously. The ones that are not iterable tend to be more like efficient on gas and whatnot. So do be aware of these collections. Okay, done with the collections part. Let's kind of go back to this section about unit tests. Let's like zoom in on these unit tests. And we see that we decorate these with a test macro. And then you do have this whole thing where we say, okay, now we're going to kind of like fake the context of a blockchain, and we're going to set that up. What's happening here behind the scenes is we can see that there's like a context builder that has some information. This is great for like some use cases, testing simple interactions with functions, whatnot. Like for instance, a good example for crossword puzzle is you want to test to see that like the winner has to have the right public key, obviously, right? So unit tests are actually fine for this. And this is a full list of like what happens with, you can kind of control with this like faked context of the blockchain. But you see here, like now that we're sort of expanding on like unit tests, we're saying, all right, here's the blockchain, you know, let's see, this account has this balance. We're kind of like just setting it to be pretty hard coded. And then the current account ID and the signer account ID, these actually are just strings. This just literally returns like alice.testnet or something as a string. So yeah, it's, you know, it's important to note that like this is kind of limited, because if you think about it, it's like, all right, well, I want to write a test that says, all right, cool, the winner should now have 10 near in it, right? Well, like Alice isn't an object. Alice is like just a string. So I can't check to see if a string has a balance or whatever. So just pointing out that it's really limited. A couple gotchas. Signer account ID versus predecessor account ID. More frequently, I would say you're going to want to use predecessor account ID. That means the person that just called me. If I am calling like a intermediary smart contract, like I want to call like a fungible token contract, and then that calls something else, then I am the signer to that. The signer means like the very first person that initiated this transaction. Predecessor is like the most recent person to call me. So there is also, knowing that, there is a little bit of a reason to use predecessor instead, because if you're checking the signer account ID, it's possible that some nefarious person could like, what's it called? Be using cross-contract calls instead. So yeah, it's important to know who's the person right next to you that just gave you that piece of paper, right?
So like so for that one, like the person, if you wanted like to reference the name of just like the user of like the decentralized application, right? Like would you use signer account ID to say like the user of the DApp like initiated this like transaction by hitting this button or something? Like the nuances between the two always kind of confuse me.
Yeah. Let's see. I'm having a kind of a hard time thinking about like because I've just used predecessor for almost everything. Yeah. So how about this? Like you are a part of a decentralized autonomous organization or something like that, and I cast the final vote on something that, you know, rewards someone or whatever. Then the predecessor would be the DAO that actually did the reward. But and then you're like, who? So who was that voted for that caused that chain reaction? Oh, that's a signer. That was Mike who actually like did that last vote.
Okay, that makes sense.
So ideas for unit tests on the crossword puzzle. Yeah, again, public key, was that right or not? Maybe you can say like, oh yeah, like this is a simple unit test, you know, almost from any sort of programming language. You know, it can't be longer than 32 characters or something like that. You can do a basic validation. And then 10 most recent winners, you know, you may want to make sure that works. Like what if someone calls that function we talked about, give me the 10 most recent winners, and there's only been 2, then that shouldn't panic or, you know, blow up. So like, these are the kinds of things you might want to do with unit tests. Yada, yada. Simulation tests are the other kind. And then there's the other kind that's coming to a near you. But for now, we have simulation tests, and this does more of what I was talking about before, where you can actually have like a proper user account, and you can say, okay, cool, like they won, their account, like object should have more near in it now. Did the winner get the reward? Did that cross-contract call that was creating a brand new account for them, did it work? Did it fail? You can do cross-contract call testing with simulation tests. Don't want to try doing that with unit tests. And then soon, yes, how much gas does this thing cost. You can actually use testing to kind of figure that out. Okay, cool. We're at 1 o'clock, and I think we can not go too much longer, but I think we're on time if you guys are cool for maybe like 10 more minutes. Sweet.
Yeah, totally. Yep.
Awesome. So here is an idea. Okay, like let's just like open up the chalkboard. Let's see what this wireframe is going to look like. All right, so ideally, let's talk about version 2, where it's just like this this front end. Okay, well, they're going to need to have a login button. Oh yeah, crap. Well, they may not have a near account, so like maybe we should have like, do you have a near account? Do you not have a near account? Okay, cool. And then see if what kind of account they want to create. So that's a good one. And then like, oh shoot, they're aloha.near, it's already taken. Okay, honode. Okay, it's taken again. Like, I'm not sure about this. And then we want to also have like the memo. And by this time, we're like asking this user to like do so much stuff, right? Like, and let's just say that we released this, we sent a tweet saying like, hey, first person to win this crossword puzzle gets 10 near, and you tweet it. You don't want someone, monkeying around with all this stuff. That's not good. It's really not good. It's very sad. So let's start over from scratch. And like, what if we just had like no buttons at all? And every key press, that they enter in this thing is an event. And the moment that they like complete the puzzle, it like, maybe it like reserves your spot, saying like, this person like, they got it, right? And as soon as you are that person, then it says like, cool, congrats, like you won. You still need to claim your reward. Do you have an existing near account or mainnet? And then it has like a little wizard like that it goes through.
So is that like kind of creating a temporary account and then doing the assignment later to the near address, or?
Yeah, see, and this is where it gets fun. Like, this is where like we haven't built this thing yet, actually, and so we can. Cool. I love it. I love the idea. Like, this is where we can kind of figure this out.
Okay, cool.
Boom.
It's almost like a temporary account, and then it's a transfer to, once it's registered, then you're doing a currency transfer.
Totally. And by the way, if you like are really kind of enjoying how beautiful my wireframe is, like I do some consulting on the side.
Nice.
I can give you a deal. So yeah, like, yeah. So stoked that you mentioned that, Jim, because so like now basically, okay, like fundamentally, like we need something unique from that winner, right? And so how about this? How about when a user loads that page for the very first time, we use that same library, your API.js, and we create a random number and a little private key that lives in their browser, their and only their browser. Nowhere else in the world ever will this little private key live. And then you have that public key from your key pair, right? You could send that public key while you submit the solution.
Yep. Cool.
And so here we go, on chain and then the front end. So what that would be is we would say, okay, the on chain had that special function call access key that was the solution. So let's like remove that, because then we only want one person to be able to use it. So let's like remove that, and then like let's add the winners to it. Oops. Yeah, and actually, does that make sense, people? So then as soon as that happens, no one else can claim that they are the first person to win it, and then the user who did claim it, they have all the time in the world to see what kind of name they want to create, and take some time making a really clever memo and stuff, and they don't feel rushed to do that all at the beginning. So this is actually a really kind of fun way to do it. And
Yep.
the person who's playing this game has no near. They have no near account. Yeah, it's like it's really neat.
Is there like a lag time? Like, could there be race condition issues with validating on chain? Like, how quick does that happen? Like, can we really make that an atomic action where you encode the solution key on the chain, or do we have race condition issues?
I mean, I don't think that there are race condition issues. It will be whoever's transaction gets in first, and
Okay.
and then like once that's saved, then it's not like two transactions can kind of simultaneously do this, which is really neat. So there will be one winner.
Okay. So the with the maybe I don't know enough about it, but would the time of submittal be like defined by the client, or is that going to be on? Is the chain, the blockchain itself, kind of deciding when the first commit to the chain is happening?
Yeah, so that one is, I think that's kind of a tricky, or like it gets into not tricky, or maybe it's more simple. Honestly, is like it doesn't really go by time necessarily. As soon as you submit a transaction, it goes into the mempool, and this is actually something where it's very similar to Ethereum. So if you read a book about Ethereum and how mempools work, I believe it's quite similar to that. And there are no rules, as far as I know, that the mempool is like you must use the ordering based on timestamp or something. Like people can just like pluck out transactions at their will, as far as I understand. So it's just a matter of, did the validator happen to choose to execute this transaction?
Yeah. Okay. Cool. Yeah. I was trying to figure out, like, this is one of the questions, like bigger questions I had. It's like how do you do like a synchronous action? Like, I submitted my answer and I get immediate feedback that I'm the winner. I'm the first one to do it, while having kind of this asynchronous distributed model of validating that's correct. Okay.
Totally. Cool. Yeah, I think in this case too, it would be almost like the person who wins will have an easier time finding out that they won than perhaps the people who didn't win will get an error.
Yeah.
You know?
So we are still submitting to a valid, like we're going to have a validation result that's going to inform the UI result. Okay.
Yes.
Okay. Cool. So if there's multiple in progress, then that validation is going to fail for other potential winners, and we're just going to kind of queue off of that.
Yeah.
Okay. I think I understand.
And actually, now that we're talking about these kind of like, I really love this, where this conversation is going, is like, then we also want to think about all the edge cases, because there's crazy people out there who do the weirdest things in the world, right? So what if someone wins, but then they just never claim it? Like, is it okay? Like, do we want that? Or like, do we say, okay, well, dude, you claimed this like 7 days ago, bro. And then do you like revert it? I don't know. But these are all the kind of fun things that you have to think about. I guess always assume that people are going to do the craziest things in the entire world. And that's how you have to like behave when constructing smart contracts.
He's looking at you, Fung.
I guess I'm the chaos monkey.
Yeah, and then I think kind of in closing a little bit is like, these are the actions that if we build this thing, and it isn't built. So this is the fun part, is like, I'm really tempted to build this, but I like want to do it with people, and like have fun together with friends. And so like, it isn't built yet. We can still do this. If we do this, we will be using all of these highlighted actions. We won't use stake, and we won't use delete account. But yeah, this actually gets into a lot of that, which is neat. A recap of the learnings. Yeah, near CLI can create keys, send transactions. We learned how keys work, how accounts and sub-accounts work, what the limitations kind of are. We learned about all the actions, batch actions, and how everyone at Near should say batch actions instead of batch transactions. Be that change. How promises work and how they're different from JS. And then the basic like sections of smart contracts, the unit testing, the sort of import section, the boilerplate. That Near collections are a thing, and probably preferable to standard collections that you see from Rust? Unit tests versus simulation tests versus the upcoming sandbox tests. Yes, and then I have a couple of extra slides here that like could probably help us along. So people have made these little crossword puzzle JavaScript things, and you can actually, some of these, I think this is the one that I highlighted. You can actually just feed in like a JSON file of like, here's the hint, and then here's the answer, and it'll actually like make the puzzle for you, which is kind of cool. So if we do want to kind of mock up something, or else just sort of like get started and see how someone else does it, there's things we can play with.
Awesome. I think it's such a cool example for people to work with. Like you get to just interact with the UI, and we could even do like sequential kind of like, hey, every month on the 5th of every month, we're going to release a new puzzle and somebody's going to earn near. And it's kind of a cool thing to put out there in the community. And then we can think about ideas on how to, have people extend the platform. Yeah, I mean, that makes a ton of sense. Like I learned a ton just by going through that and realizing how that would actually work on a distributed blockchain. Like,
awesome.
That's pretty cool.
Yeah, it's funny. So have you met Josh Ford, Jim?
Yeah. Yep.
Nice. Oh, actually, yeah. I think you had a human time with him, like your first day, if I remember correctly.
I did. Yeah. Yep.
Nice.
Yeah, he was one of the first. Yeah.
Yeah. So his partner has been like had a history of making crossword puzzles and solutions in real life, like, and she still gets paid like monthly, like for these crossword puzzles. So like this is another cool thing is like, maybe that's like version 5 is like people can submit, crossword puzzles, and then they can, I don't know, just make a community where everyone's kind of involved and people are still winning money. I think it'd be cool too, since Near has worldwide presence. You could like your idea of having like once a week like release them. It'd be fun if it's like once a week in 3 time zones. India Standard Time. Like Moscow and Pacific or something like that.
Totally. You could have language specific, region specific. Yeah, it'd be super cool. It seems like really accessible for like Web 2.0 developers or Web 2 developers to actually understand like, oh wait, okay, I just did this thing. What's actually going on behind the scenes? This isn't going to like a centralized server, AWS or whatever. I like that. I think we can have like examples that are more complex on how to write a really sophisticated smart contract, and then examples of wait, why would I ever do this? Like how does this work behind the scenes?
Yeah,
I think this would be a great like intro example.
Mm-hmm.
Radical. Well, yeah. Thanks y'all for coming. Like I made this presentation. Like it probably took me like 35 hours to like actually make this presentation and come up with the idea. It's so funny how short it goes, but like a lot of thought went into it, and like I was like dying to like tell people, and so I'm like super psyched that it seems like you all like really get it and hopefully learn something. So yeah, that really feels good, and I appreciate everyone's time. I know it's gone over.
Yeah, but Mike, what do you think with the? Sorry to keep extending, but what do you? How much time do you think it would take to implement, version 0?
I think like
this.
Well, yeah, like I could probably write it in like one day, but I really want to do it with friends. I really want to do it with everyone, because like really the fun of it is like, wait a second, what about this? And then you sort of like figure it out. And like I also like really don't want to be the person who's like assigning tickets, like because this is supposed to be fun, and it is fun, right? So I would say like 2 weeks of people hacking together.
Cool. It could be fun for some of us who are new to smart contracts to take a stab at it and then get some supervision and some input on how we're doing it. It could be a really fun like onboarding tool.
I think that'd be awesome. And like it's also like so it's fun, and then also I am realizing like when I was getting into kind of cutting my teeth on smart contracts, it was like high stress. It's like I need to do this for a partner because they are like building on Near, and like we can like people don't have to get thrown into the Shark Tank, and we can have fun. So like I do kind of want to like encourage people to learn this, because otherwise it is quite possible that people will get assigned to have more like, hey, you really need to help them do this and achieve it. But before it gets, that stressful, like we can all have fun doing this, but yeah, hopefully we can cut our teeth like on a more hobby project.
Yep. I like it. Yeah, it'd be super fun. Like, I kind of want to go like work on it.
Yeah.
flail on it.
Tomorrow's Hack It Friday, and let's do it.
Yeah. All right, cool.
Yeah, this is definitely really cool. Thank you for like putting us together. I definitely would also have to see more of like these kind of like dives into different like near concepts and like applications. Like things were really helpful.
Awesome. I appreciate that.
This is definitely like this run through this whole entire process is pretty good for me as well. Like
Awesome.
just haven't been able to watch the video you sent me before about, you recorded this before, right?
Yeah, I think this one was better. So yeah.
Yeah. Are there any like, so I guess like instead of wait, which collections are we using for this one? Like, is it like a lookup map for this? Or would it be like
It's a hash map right now.
Is it a hash map right now?
Yeah.
Would it be like helpful to like use like one of the near collections?
And this is where I have an answer, but like this is where we build.
I think it'd be useful.
Should it be iterable? Should it not be? Like these are the questions.
We can run it through the simulator and get all of our metrics out of the simulator. Prove that concept too.
Yeah.
Or not simulator, sorry, the sandbox.
Yeah.
For those iterable collections, like do you have to run into the same like issue where you have to like pull in the entire like sum of all the data, like you're saying with the like no?
Yeah. So the iterators, and I mean honestly, Fong is probably better speaking to this possibly, but like the way it's stored in state is like you are iterating through it, but it's like, give me that one, now give me that one. It's not like, hey, load all these guys and then like loop through them. So it is, if that's what your question is, like, it is not doing the bad stuff the hash map is doing.
Okay, so it's like, how does it pull? It doesn't pull like all the data at once and then like iterates through the model. It just like pulls like references to it or something. Or what?
Yeah, I guess it just does reads inside of where it knows where it's located, and then it just does reads, which is funny because it's easy for me to, when I was hearing this, to be like, okay, in that case, it's 100% better every single time. And then working with Eugene, that became quickly clear that like, no, there are times too where like it makes sense just to do one. If you know that you are always going to need these five things and you're never going to not need them, then do one read, right? Because a read costs X amount of computation, X amount of gas, right? So there are also cases where you do want to use hash map. Yeah.
Oh, interesting.
So you're only storing like kind of the key side of the key value pair, and then you're very lazily looking up the results. But if you're gonna, so there's a penalty there, right? So you're having to make a explicit call to pull back values based on that key. But if you know you need all of the values, you just pull it all in at once, and then it's super efficient. Is that kind of the idea?
Yes, 100%.
Cool. Cool.
And this makes me want to also show this real quickly. Is Josh Ford did a really cool graph.
Page.
Yeah, have you seen this? I don't think you've seen this, Jim. And maybe not Fong too. So I'll share it. This was something that Josh was coming over to my house for a bit, and we were like hacking on this, but he did it all. I just tried to like help guide. This is like really, really, really useful. I'll actually go down to the Rust collections down here. So here's them all. Tree map is like iterable, and you can clear all values, and here's the preserves order of insertion, all that stuff. Then he goes down into big O notation, which is awesome. So you can see the efficiency. Cool. And then gas consumption examples. So he ran this against testnet, just because we were going to do simulation tests, but then testnet was actually a little bit more accurate. So now you can see how much it costs. So this is for inserting data, and then below is for retrieving data. So you can see that lookup map is like the lowest. And one thing to note here is tree map is like self-balancing, so it'll never get like super deep. But and this is perhaps something we should call out more. But up here on these two, the maximum is 3.0. Over here, it's 20. So 3.0 is down here. So tree map is like way more when it comes to insertions. However, you can see that the tree map is a little bit cheaper when you're when you're retrieving it, right? So yeah, it's all about trade-offs. But this is a good page to reference when you're like, which one should I use?
Cool.
Yeah, that was always good.
It's funny for me to have to think about like big O results, but also gas.
Yeah.
You know, it's like another, you know, another vector there. And interesting.
Awesome. Well, I am super psyched now. Like, I don't know, I feel alive after this meeting, and want to thank you all for being here and listening to this thing that I spent so many hours on, and the validation and all of that. And I was a little tired coming to this meeting, and then now I'm just like psyched and getting ready for Hack It Friday.
Awesome.
Yeah,
dude, let's figure out how to put this on the agenda. I think this is a super, I mean, for me coming into it, like, again, it's just, it makes me have a context for thinking about some of these ideas. So I think it's a great thing to invest some time into.
Awesome.
Yeah, definitely like jumping on too. Like always like looking for like, I think working in group would be, I mean, I'm always looking for new opportunities to learn. So I think like working in group would be like very helpful for this project, very helpful for me personally. Yeah.
Cool. Well, I invite you to play hooky and join us on Hack It Friday. Awesome. I'm going to stop the recording and